So for our roll report, our project is testing how fast Madagascar hissing cockroaches can right themselves when they're placed on either a smooth or rough surface upside down. Madagascar hissing cockroaches are a type of cockroach found on the island of Madagascar. They're usually found in hollow logs for protection from the outside environment and predators. They scavenge for food like fruits and decaying plant and animal matter. Unlike many other cockroaches, the Madagascar hissing cockroaches don't have wings and are widely known for their specific hiss when they're threatened or if they're trying to attract a mate. Madagascar hissing cockroaches, like many of the forms of cockroaches, have a set of tarsal pads that are used for climbing structures and providing traction on the rough surfaces when climbing. We hypothesize that the Madagascar hissing cockroach will right themselves faster on rough surfaces rather than a smooth surface. Alright, so now that we've gone on background, I'm going to discuss the experimental design for our project. First, I'm going to go over the materials we use for the project. These materials include plexiglass, which we use for a rough or smooth surface to have the cockroaches ride on. And then we use foxgrass for the rough surface to have the cockroaches ride on. And then we use random adult cockroaches for the experiment, so we'd have completely random results. And we also use a stopwatch on our phone to test the speeds of the cockroach riding. For our design, we had multiple test days consisting of 3 tests each. For our experimental design, we had to drop each random cockroach from the same height of 2 inches from the surface on their backs. And for our controlled variables, we had to make sure the drop of our cockroaches from the same height onto their backs to have consistent fair data. We also had to use the same rough and smooth surfaces every time, so the cockroaches would have fair trials as well.
And here we have the data found from our long-term experiment. Listed, we have the time it took for Madagascar hissing cockroaches to right themselves on smooth and rough surfaces. While there is a difference, is it significant enough to matter? If you look at the data, it would appear that there is an overt trend and that the biggest difference in times is in trial 10, with smooth being 4.1 seconds faster, and the smallest difference is in trial 7, with only a 0.6 second difference. Our average smooth times were 1 whole second longer than our rough trials, which is a big difference when some are only different by tenths of a second. But is it significant enough to support our hypothesis? Since we are comparing the differences in times, we decided to use a line graph to help us better illustrate the differences in the times it took for Madagascar hissing cockroaches to right themselves. On the x-axis, we have labeled the trials, and for the y-axis, we have labeled the seconds, since that is the dependent variable we were testing for. The line graph better shows us that the last 2 trials seem like outliers. This extreme data point could be the result of having a tired or lazy Madagascar hissing cockroach. But looking at the rest of the graph, the rough is very low and consistent, while the smooth is inconsistent and took longer to right themselves. However, we cannot claim that our hypothesis is true just from looking at our graph. So we must use statistical analysis and a t-test to determine whether or not the difference is significant enough.
So, for the t-test, we found the mean of all the times for how fast it took for the Madagascar hissing cockroach to upright itself on both smooth and rough surfaces. Our average time for the smooth surface came out to be 2.06 seconds, and the average for the rough surface came out to be 1.65 seconds. With this information, we were able to calculate the degrees of freedom to be 18. Furthermore, we calculated the T and P values at 18 degrees of freedom and at a 0.05 significance level. This got us 0.618 for the T value and 0.688 for the T-table value. And finally, for the P value, we got 0.272. The resulting p-value states that there is a 27.2% chance that our results were due to random chance. For standard scientific investigations, a critical value of 0.05 or 5% is routine, and since our critical value is 27.2%, this means that our results are not that reliable according to scientific standards. If this experiment were to be replicated again, the number of replications for each treatment should be increased to have more confidence in the results.
So, from our experiments over the course of the semester, we have found that the Madagascar hissing cockroaches were able to right themselves faster on rough surfaces as opposed to smooth surfaces. This is because their tarsal claws were able to grab hold of the rough texture of the fake grass. This shows that in the wild, the Madagascar hissing cockroach would most often be found on rough surfaces with a lot of distinct features such as grass, rocks, twigs, and other objects coating the bottom of the jungle floor. The roach also has tarsal pads which allow it to grip smooth surfaces like leaves in the wild. However, the tarsal pads often do not provide the roach with enough grip to be able to flip itself over onto the smooth surface of the plexiglass. The results of this experiment proved sufficient. However, they could have been made more accurate by setting up a controlled and consistent way of dropping the roach onto its back, as there were a few times that the roach would fall upright or sideways. The implications of this experiment show that the Madagascar hissing cockroaches often do not encounter perfectly smooth and flat surfaces in the wild like the plexiglass. This helps us better understand the environment of the Madagascar hissing cockroach has evolved in. We can surmise that their habitat consisted of rough, varied terrain with many objects to grab hold of. The absence of wings may also be a factor in how quickly the insect rights itself, and winged insects may have more success in this activity. We also observed that the cockroach would arch its back and kick its feet to try and grab hold of the surface, and would repeat this action until it was able to pick itself up again. The amount of arching and the width of the roach seem to be the variables that distinguish each roach, and thinner, more agile roaches may be able to right themselves faster than wider, less nimble roaches. So, that is all the information we have for our presentation. Thank you for listening.